Hey guys, what's up? Mr. Mathematician over here. Today I'm going to show you how to find HCF using Euclid's division theorem or Euclid's division algorithm. Now, what the theorem says that is dividend equals to divisor into quotient plus remainder. Now we'll find HCF using this. What is HCF? It's highest common factor. Now we all have studied HCF in our earlier standards. So now let us take an example. Let us take 135 and 225. We'll find highest common factor of these two numbers using Euclid's division theorem. First, the number that is larger, that means over here it is 225, will use as the dividend, and the number that is smaller will be used as divisor. So that means we'll divide 225 by 135. We'll take 1za because 2za is bigger. So 135, we'll subtract 135, we'll get 90. Now what we need to do is we'll take 135 as the dividend and 90 as the divisor. But first we'll write down an equation, that is dividend, in this case 225, is equal to divisor into quotient, that is 135 into 1. So we'll write 135 into 1, 135 into 1. Now plus remainder. What is the remainder? Over here it's 90, so we'll add 90 to it after that. Now we'll take 90 as the divisor and 135 as the dividend. So now we'll divide 135 by 90. So we'll have to take 1za, we'll subtract 90 from 135, we'll get 45. Now we'll do the same, we'll write it for 135 also. That means 135 equals to, now we have the divisor as 90 over here. Dividend is 135, divisor is 90. So we'll write 90 into 1 again, because 1 is the quotient, and we'll add 45 to it because 45 is our remainder. Now we'll take 45, that was our remainder, as divisor, and we'll divide 90 by 45. So we all know that 45 2za is 90, so our quotient would be 2 over here, and we'll subtract 90 from 90. Now over here we have 0, so we got our remainder as 0. Now we'll write for the same equation for 90 also, that is 90 equals to 45 into 2, that is our quotient, plus 0, that is our remainder. So over here our HCF of 135 and 225 would be equal to, that would be the last divisor. That means in our first part the divisor was, as per our equation, the divisor in our first part was 135, in our second it was 90, and in our third part it is 45. So 45 would be our HCF of 135 and 225. It doesn't matter how many parts you have, but in the last part, when you get the remainder as 0, the divisor would be your HCF. In this case, we have 45. Let's take another example. Over here, I have 196 and 38,220. Quite a big number. We'll take the bigger number the larger number as the dividend, and we'll divide it by 196. That means we'll divide 38,220 by 196. We'll have to take 1za because 2za would be larger than 382. So we'll take 1 over here and we'll subtract 196. We'll get 186. Now we'll bring the 2 down. So we have 1862. We'll take 9 and it would be 1764. On subtracting it, we'll get 98, and now we'll bring the 0 down. So we have 980 over here. Now we'll take 5 196 into 5 would be, we'll get 980. So our remainder would be 0. Now we'll note down this step. So we have 38,220 equals to, that means dividend is equal to divisor. Over here our divisor is 196 without dividend equals to divisor, that is 196 into 195. As 195 is the quotient, we'll write 195 and then we'll add 0 to it. 0 is a remainder. Over here in the first try we got the remainder equal to 0. So 196 is the first and the last divisor over here. So 196 would be our HCF of 196 and 38,220. That's just because it was the first and last divisor. I hope you like the video guys and enjoy the video. Thanks for watching.